Okay guys, I'm going to try to go fairly quickly through some graphing of cubic functions. Now ideally you'd like your cubic function to be in factor form, so if you haven't factorised it already you might need to use the factor theorem to do so, and once you get it into factor form we then work out the x-intercepts by letting y equal 0. So typically what you do is what you do with any function, x-intercept y is 0. So that means either x minus 1 is 0, so we could therefore say x is 1, or if x plus 2 is 0, x would be minus 2, or if x minus 3 is 0, x would be 3. To find the y-intercept, we let x equal 0. So if you look back at the function and we made x equal to 0, those brackets would just become negative 1 times positive 2 times negative 3. So what would that give us? That would give us positive 6. Alright, so the next thing to do is to do a sketch of that. Now when you sketch a cubic you can have up to 3 x-intercepts, and in this case we have got 3. So our x-intercepts are at 1, negative 2 and 3. So this is going to be the point 1, 0, negative 2, 0 over here, and 3, 0 over here. We also know our y-intercept at 6. Let's just make that over here. We'll call it 0, 6. Now, when you do your cubic, you've got to decide ultimately where it's going to go when x gets very large. If you look at this cubic, you'll see that we've got x minus 1, x plus 2, x minus 3. Well, they're all positive x's, aren't they? When you time, if you were to times it all out, you'd get a positive x cubed term. So that means as x gets very large, x cubed will get large. So it means you're going to end up heading up in that direction like that. Okay, now what we're going to do is weave through each of those intercepts. So we actually know we're going to be heading up in this direction. We're going to have to cut through there. We need to turn at some point. It's not necessarily going to be in the middle. We're going to turn here. We're going to have to cut through 0, 6 and negative 2. Now, although it's not going to turn midway between exactly, that's not a bad idea to say that it may do so, so it'll probably keep rising a bit here before it then turns and goes down. Okay, so that's how we do that one. Now, what if we had one that was factorised like this? What we can see straight away is that we have this negative x term here, a positive x term here, and a positive x term here. So that's going to give you a negative cubic if you were going to expand it out. So ultimately when we draw this one, we expect it to be heading downwards in this direction as x gets large. Okay. Now you can probably guess what the x-intercepts are from here. You say to yourself, when will 3 minus x equal 0? Well, that'll happen when x is 3. So we're going to have a point here at 3, 0, an intercept, and at x plus 2 will be 0. When's that happening? That's when x is minus 2, so that'll be over here. And likewise, when x plus 1 is 0, well, that'll be in there, so I've had to squeeze that in. Now we've got to weave a cubic through that, and we want it to go down ultimately. So it's going to do something like this. It's probably going to turn roughly halfway between those intercepts, and then it's going to have to turn again to go up like that. Okay, that's a pretty crappy diagram, but you sort of get the picture. I'm trying to rush a bit here. Now the other thing I wanted to show you was if you have a repeating factor. Okay, so again, if these things aren't factorised, you're going to have to use the factor theorem to do it. That's what we did at the end of last term. So but once you've got it factorised, let's say you have something like this. You've got x minus 1, and you've got, well, let's make it x plus 3 squared. Okay, whenever you see a repeating factor like that, a squared, that means it's going to touch the x-axis. So you can think of 2 and touch, alright, 2 touch. So let's just draw that. We're going to have a touch at x equals minus 3, and we're going to have a cut at x equals 1. So we'll have a point 1, 0 over here. Now again, we've got to decide, is this thing going to be going up ultimately or down ultimately? So we look in here, we've got an x term, that's a positive x. This is another positive x which is being squared, so everything's all positive, so it's going to end up heading up in this direction. Now we know we need to touch at the point 1, 0, so we're not going to head straight to it. We're going to come in and look to almost land and then take off again. And we know at some point we're going to have to turn Where do we turn? Probably roughly halfway between these two intercepts, but we can find that point out later. There's other ways of doing that. So it's going to turn and go down like that. So that's what we end up with our sketch there. Okay, so what do we do if it's in turning point, or not turning point form, but like point of inflection form? A little bit like what we had when we had quadratics. Remember we had things like x minus 2 squared plus 3. Well, here we've got a cube term instead. So when we go to sketch this one, this is turning point form. Well, I call it turning point form, but it's really a point of inflection, POI. So the point of inflection here is going to be 2, 3, very similar to what we did with quadratics. Okay, so when we sketch that, we've got a point of inflection at 2, 3. So we'll approximately place that in. Let's call this the point 2, 3 and mark our x and y intercepts in. Now, checking out, is this going to be a positive cubic or not? Let's have a look here. That's a positive x and it's going to be cubed. It's still going to be positive, so it's going to end up going up in that direction there. Okay, now we want to have a point of inflection at the point 2, 3. So what we're going to do is just draw that in like this. So we're going to be going like, whoops, we're going to be going like this. Alright, so it's going to be inflecting and then ultimately heading up. Now this bit here is going to head down. Now where is it going to cross? Is it going to cross over here or over here? We don't know that at this stage, so we're going to need to find our y-intercept. So the point of inflection tells us that we have a gradient which is 0 at the point 2, 3. Inflection points, what happens is the gradient continues in the same direction. We're heading up here, we flatten out, and then we start to head up again. Alright, so what's the y-intercept going to be? Well, the easiest way to find the y-intercept is to let x equals 0. So we do that, and we're going to get y equals, instead of x, we'll just drop that out. So we've got minus 2 cubed plus 3. Minus 2 cubed is minus 8. Minus 8 and 3, what's that? That's minus 5. So somewhere down here at minus 5, we're going to have our y-intercept. Alright, now you can see for the graph to get there, we don't want to cross across here because then we're going to miss it. So that's not going to be the case. It's actually going to go like this. Alright, now you want to make this region fairly obvious. You don't want something that just looks like a straight line. You want to make it pretty obvious that there is this inflection point here. Okay, so you can always draw your inflection point and then work out your other bits. Now what if it's a cubic inequation? So instead of equaling 0, we've got less than or equal to 0. Well, look, what we do is just treat it as though it is equal to 0 initially, so that we get a sketch of the graph. We can check here, we've got a positive x, a positive x, a positive x, so it's going to end up heading up that way. Now our intercepts are going to be at minus 3. There's going to be one at positive 2 and positive 1, so I'll mark those in here. And we know we're heading upwards. There's no touches, there's no repeating brackets, so it's got to weave through all of those and it's got to end up heading upwards in that direction. So again, don't go straight at this point here. You've got to sort of come in for a soft landing, so come in this direction. No, so what am I talking about? It's not a touch. Okay, so what we do is we do come in like this, we cut there, we're going to have to turn, cut here, and at some stage we're going to have to turn and cut over here. Now of course we can find the y-intercept if we want to, but we don't care about that at this stage. We just want to know is when is this thing less than or equal to 0. So what we'll do is just mark a few points where the graph is less than 0. Alright, so here are some points. I'll just make those a little bit bigger and more obvious. There are some points where the graph is below 0. Here are some points where the graph is below 0. Alright, now we want less than or equal to 0. So we would say here that the x values that we want are x has to be less than negative, what's that, negative 3, less than negative 3. So we'd have x such that x is less than or equal to negative 3, as well as this section here from 1 to 2. So we could say x less than or equal to 2, but greater than or equal to 1. Alright, so that's how you do that. Now, of course, the alternative way is to use those square and round brackets. You could say less than or equal to negative 3. Well, that's all the way from negative infinity up to and including -3, as well as the section from 1 to 2, including 1 and 2. Just perhaps try to get up to or complete the stuff in exercise 6F if you could, and I'll take it up from there when I see you next week. Okay, bye for now.